In this video I want to show you a more realistic example of the kind of problem that you will encounter. Here's a very short extract from a phone call between Marsha and Ron. Ron has called up to see if Gina is there, and he asks Marsha this.
No.
Has she moved? And Marsha replies, no.
No. No.
Now, I think you can hear that very clearly as a very abrupt fall in intonation. It goes, no, not no. And if we zoom in on this,
No. No.
what you can see is something that looks utterly different. What you see is an F0 contour which rises and then falls a little bit, but what we're hearing is not a little bit of a fall, but quite a dramatic fall. So this video is about why that would be. If you highlight the voiced part, that is the part where PRAAT can find an F0 and listen to it, what you'll hear is this.
No. 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 No.
And now I think you'd agree that what you hear is like what you see. So the question is, what's happening in the other part
Oh. Oh. Oh.
there? And the answer to that is two things really. One is that there is indeed and very audibly a very abrupt fall in F0.
Oh. Oh.
Also this very abrupt change in amplitude, which you can see. You can also see towards the end, I think here particularly, these big glottal pulses which suggest a different kind of phonation than the regular phonation that's going on here. If you listen to the voice quality here versus the voice quality here, that's much lower and it's a bit more irregular. So the reason that PRAAT is not showing you a fall here is because PRAAT is having trouble working out whether this is voiced or not. In fact, it thinks that it's not voiced. If we zoom in on that part, oops, we have to go selection, and we just zoom in a few more times, trying to get the right part. Yeah, there we go. You can see that the waveform is kind of choppy, and it's very hard to see periodicity in this. All you see is lots of ups and downs, but you don't see very much of a pattern in there, and certainly compared to what's in the previous section, PRAAT is struggling. Now you can possibly fix that, and one way to do that would be to do this trick, which is to have PRAAT generate a pitch trace, as we saw in an earlier video, and then go to View and Edit. And now we've got a problem because we need to make sure that we've got the same bits highlighted. So there's the no.
No.
Okay, so let's select that, and we'll go and select it again so we don't have all that nonsense around it.
No. No.
Now when we look, see I've got this group button ticked here, so with luck, there we go, we've got the same thing showing here. Now you can see that the trace that PRAAT has found is what we saw in the window. But with your eyes you can also see that PRAAT could find another path through there, something like that, just doing it by eye. And that's quite a bit closer to what we can hear. Now, what are my reasons for clicking that? One was that that seemed to me to be visually the best way through, but a more kind of scientific way of expressing this would be, remember that each one of these numbers represents a probability in PRAAT's view of whether it's voiced, and if it's voicing, whether the F0 is at this level. So if you look at the numbers that I've chosen, there's a 3, which is a low number, but it's the highest one in that particular column, There's another 3, that's also the highest in the column. Here there's a 5, there are a couple of other 5s, one would be here and one would be there, but neither of those continues the trajectory that's already been started, and normally F0 follows a relatively smooth line because we're human beings. The next pitch point is there, and that's the that's number 4, that's the highest number in the column, that's the highest number in the column, and so on. So that's how you might be able to fix that and produce a pitch trace which actually does represent what you can hear.
No. No.
Even if PRAAT originally can't do it. So sometimes there are ways of fixing things too. And that's why I think it's very useful to make this kind of a pitch trace rather than just work with what you see on the screen. Aside, of course, from the fact that you can make nicer pictures with this than you can with the one that has the spectrogram too.